Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Identify the structure. The compound is 1-methyl, 4,1-propylidene, cyclohexane, specifically a cyclohexane with a methyl substituent at C1 and an exocyclic double bond at C4 of the form is equal to CH-CH3. Moving on to the next step. Identify potential stereocenters and sources of stereoisomerism. C1 bears a methyl group, 2 different ring carbons on each side. We need to check if it is a true stereocenter. In a 1,4-disubstituted cyclohexane with an exocyclic alkene at C4, C1 has H-CH3 and 2 ring chain arms going to C to C6 and the other side. C4 has the exocyclic double bond is equal to CH-CH3, making it sp2, not a stereocenter itself. The exocyclic double bond C4 is equal to CH-CH3. For EZ isomerism to exist, the 2 substituents on each carbon of the double bond must be different. C4 is part of the ring, its 2 substituents are the 2 ring halves, CH to CH2 on each side leading to C1. Because the ring is symmetric at C4, both sides of the ring from C4 to C1 are identical, CH to CH2 chains, the 2 groups on C4 of the double bond are identical. Therefore, there is no EZ isomerism at the exocyclic double bond. Moving on to the next step. Check C1 as a stereocenter. C1 has H-CH3 and 2 ring paths. One path goes C1C to C3C4 is equal to CH-CH3 and the other goes C1C6C5C4 is equal to CH-CH3. Both paths are identical in connectivity. Both are CH2CH2C is equal to CH-CH3 dash. Therefore, C1 is not a stereocenter. It has 2 identical substituents. The 2 ring arms are mirror images of each other and in fact identical. And for the final step. Since there are no stereocenters and no EZ isomerism, there is only one stereoisomer of this compound, the compound itself. With only one stereoisomer total, there are 0 diastereomers. Diastereomers require at least 2 different stereoisomers that are not enantiomers. A, 1, B, 2, C, 4 would require stereocenters or geometric isomerism, neither of which exists here due to the molecular symmetry. Therefore, the correct answer is D. Therefore, the correct answer is option D.